So welcome back. We're going to continue our lesson on scientific notation. We have some examples here. We want to write the following in decimal notation. I'm sorry, we want to write the following in scientific notation. Right now, these guys are in what we call decimal notation. Or some people use the term standard notation. So these right now are written in decimal notation or standard notation. These are. This one, I don't know what that one's in. That's just in some strange form. That one's not in scientific. Notice how it kind of looks like scientific notation, but this first part has to be between 1 and 10, and it's not. Same way here. Notice how this number is not between 1 and 10. So this isn't quite in scientific notation. So we got some work to do on those. So let's look at the first example. We want to write this in scientific notation. So the first thing we need to do is determine our A. Now, to determine our A, what we end up doing is, remember our decimal is over around the end. What I need to do is move my decimal over until I create a number that's between 1 and 10. So I got to slide it over 1, 2, 3, 4, 5, 6 spots. If I move it 6 spots over, notice that I create a number 5.4. So just move that decimal all the way to the end until you just have one spot left over. That's going to create a number between 1 and 10. So I'm sliding it over until I create a number that is between 1 and 10. 5.4 is between 1 and 10. And we had to slide the decimal over 6 spots. Since we lost 6 spots, I got to put a 6 to the 10 to the 6th power to put those 6 spots back in. So 5.4 times 10 to the 6. Remember, 10 to the 6 means to move the decimal 6 places to the right because you're multiplying by a 6. So this is equivalent to this. So 5.4 times 10 to the 6 is in what we call scientific notation. So notice how I created a number between 1 and 10. I looked at my decimal places. How many did I move it? I moved it 6. What I got to pay attention to is since I lost 6 places, I got to make that a positive 6 to make the decimal move back 6 places to the right because this has got to be equivalent to this. And that would make sense. So you're going to see that if the number is a really big number, we're going to be using positive exponents for that, to express that. Let's look at this example. I got to make the decimal move till I get a number between 1 and 10. If I move it there, that's only 0.9. I actually got to move it to the other side. I got to move it over to that spot. So when I do that, what I end up with then is this 9. Now, what I see from there is how many places did I move the decimal to make a number between 1 and 10? Well, I moved the decimal 1, 2, 3 spots. So notice how when I moved it to the right, I gained 3 spots. So what I got to do is offset that by putting a 10 to the negative 3. That 10 to the negative 3, remember, it means you're dividing by 10 3 times. So 9 times 10 to the negative 3, that negative 3 would mean to move this decimal back 3 spots, and that would be the same thing as this. So this is what we call scientific notation. Decimal notation, scientific notation. So again, these are supposed to represent the same thing. So what we pick up on is if you have numbers that are smaller than 1, in other words, if you have decimal numbers, we should be using a negative exponent to represent that because remember, that negative 3 is going to make my decimal move back 3 places to the left. Let's look at example number 3 here. Again, I got to put this in scientific notation. So the first thing I get is move it 1, 2, 3, 4, 5, 6. I got to move it 7 spots to create a number between 1 and 10. So I now have a 2 there. By moving it to the right, I gained 7 spots. I got to use a 10 to the negative 7 to offset those 10 spots. So 2 times 10 to the negative 7 should represent that. And remember, 10 to the negative 7 means you're going to divide by 10 7 times. So that decimal is going to be moving 7 places back to the left. And that's going to give me my decimal notation. So that would be correct because my A is between 1 and 10, and my N is a negative integer. So that checks out. So 71 times 10 to the 3rd. For me, that's not in scientific notation. What I want to do is maybe take a step back and then move a step forward. Let's put this in decimal notation. I know that 10 to the 3rd basically means to multiply by 10 3 times. So in other words, that's just going to change that to 71,000. Because each time you multiply by 10, that's going to increase your place value by a place spot. So I'm going to move my decimal 3 places to the right, or in other words, add 3 zeros. Now, to put it in scientific notation, I got to make this a between 1 and 10. So remember, your decimal's over here, and you have to slide it over 1, 2, 3, 4 spots to create a number between 1 and 10. So I create this 7.1. Now I got to multiply by 10. Now notice how we lost 1, 2, 3, 4 spots. So I got to put those back in by putting a 10 to the 4th there. So 7.1 times 10 to the 4th would be the same thing as 71,000. Because remember, that means you're going to multiply by 4 tens. And if you multiply by 4 tens, that's going to slide the decimal 4 places to the right. And that would give you your 71,000. So that would be what we call scientific notation. Notice how the a is between 1 and 10. And your exponent is a positive integer. So let's look at 33 times 10 to the negative 30. Now again, this is not scientific notation. What I want to do is maybe take a step back and then go a step forward. So the 10 to the negative 3 means to actually slide the decimal 3 places to the left. So notice how my decimal's there. So that's going to change that to 0.033 because I have to move it over 1, 2, 3. So this can be changed back into decimal notation. And then from decimal notation, it's easier to go ahead and move it back into scientific notation. So to make it scientific notation, this decimal's got to move over 2 spots over to make a number between 1 and 10. So that gives me 3.3. 3.3 is between 1 and 10. And notice how I gained 2 spots, so I have to offset that by putting a 10 to the negative 2 there. So that would make me lose 2 spots back. So 3.3 times 10 to the negative 2 would be equivalent to this. Because remember, a negative 2 means to slide your decimal 2 places back to the left, and that would be the same thing as that. Because remember, 10 negative 2 implies dividing by 10, and dividing by 10 makes that decimal move to the left. Also notice that, since it's a negative number, we also know that negative numbers mean go left. So there's some same kind of concept there. All right, got one more example, 4.8. Notice that 4.8 is already between 1 and 10. So I can change this to then 4.8 times 10 to the what power? Remember, I can't change the value of it, so the only thing I could be multiplying 4.8 by would be a 1. But how do we make a 10 turn into a 1? Well, don't forget, we have what's called I'm waiting for it, a zero exponent. So I can write that as 4.8 times 10 to the 0 power, and that would mean the same thing as 4.8 times 1, or 4.8. But that would now be in scientific notation because my a is the 4.8, and my integer is a 0. So my n is a 0, and we succeeded. We got those in scientific notation. So let's move on. I think we're going to go the other direction. We're going to give you some things in scientific notation, and we're going to put them back into a standard notation. So stay tuned.